Hello, hello, people of the internet. And welcome back for some more laid-back game development. Let's make sure I have the audio stuff set up correctly. Kind of looks like I have. But do let me know in the chat if I don't. And we can get started. So this will be an evening stream for me. Not sure how long we're gonna go today, but we're gonna go a little bit. And we will work on the handbrake today for traction point. One of the things that I got quite a bit of feedback in pre-alpha 1 regarding was the handbrake. Yes. Just making sure I have synced my code here properly. So, the handbrake. so far has been a little bit unclear, maybe. And to be honest, it has been something that I haven't really done myself. I've sort of outsourced it to the PhysX SDK, the PhysX Vehicle SDK. So you've been able to apply the handbrake like this. It takes a while for these wheels to actually stop. Let's go with a smaller vehicle here. Take this guy. And we can see that if we apply the handbrake, then the rear wheel just stops completely. And that's been all well and good. We have another vehicle. We can see that it actually kind of engages its handbrake when it's just standing there. So now if we try to push this guy, we can see that we can't really push it. It has its handbrake turned on, and typically you can do it if you just hit it hard enough. Oh, you can't actually do it now because I've changed the system a little bit. Let's see if we can find a. I think I had an older build of the game here on the desktop. Whoa! I'm hitting my microphone. Sorry about that. Let's see. And that's a really old build. Maybe not go with that. Well, actually, why not? Let's see what we have. Let's see what we have here. So plane and car. This is a level that is just basically just a flat plane. There's a car sitting on it, as we can see. And here we have the same thing. If we try to push this thing, it kind of resists. Almost, actually got it to release its handbrake almost immediately. I think we can maybe, yeah. Now we can see that it's kind of like it's resisting it a little bit. We can't actually push it like this. But if we take a little bit of an effort, we just smack into it. It kind of is. Kind of gets released. And then again, if we kind of let it stand there for a while, the same thing happens again. And that's something that actually I don't really do anything for myself. This is managed by the Vehicle SDK. And specifically it uses something called sticky tire constraints. The sticky tire constraint is something that the Vehicle SDK enables, activates, to essentially make it easier to keep a vehicle in place if you just leave it somewhere. And that's a very useful thing to have, but it hasn't really been obvious when it has been on, except you've been able to kind of just bump into things and see if they roll away or not. But other than that, you haven't really been able to control it. You haven't really been able to even query for it. And that's something that I've been actually exposing lately in newer builds. So first of all, I added a handbrake controller here, which has a few of these states. We can actually enable debug print. Let's turn on debug printing here. Quickly do a rebuild. It should be really fast. So there's a few states. The handbrake is not currently active, that's inactive. Then we have active by input and active. And active by input is basically what happens if you are driving around and you engage the handbrake. For example, to initiate a skidding maneuver or sliding around a corner or something like that. Something you would typically do in like a racing game or something like that, right? This sort of thing where you're still moving, but you're holding the handbrake to kind of flip the car around in some way, like that. That is active by input, and we can actually see now that we've enabled this thing, this output. You can see it mixed in with some HUD outputs there. But those things that start with handbrake controller, you can see it actually transitioning from one state to another. So it kind of goes from inactive to active by input, and then back as I let go of the key. And so that's one state. And active by input essentially means that the handbrake is active, but it is active because the player, or in the case of an AI agent driving around with the car, the AI brain is actively giving it the handbrake input. Like this. Let's see what happens if I let it stop. Then it goes from active by input to active. And this now means that the handbrake is active. It is not going to be disengaged even if someone drives into this thing. So now that we have this car here, I can spawn another one, switch to that, and now we can't really disengage that handbrake at all. It is on, it is active, it is not going to come off. You can't really push this guy at all. And this is very important because, like, if you're messing around with the crane on the mother vehicle, for example, you don't want you don't want impulses that are large enough to be able to disengage the handbrake, as was previously possible. So if we lift this thing here, then we start to like violently move it around like this. In pre-alpha 1, this would actually have disengaged the handbrake most likely. Of course, if you're doing this with the full vehicle, then all the more chance of that happening. But you can see that the handbrake now stays on, and it is not disengaged. This vehicle, at least most of the time, it kind of stays in place. Might move just a little bit if you're nudging it hard enough, but that's kind of expected. The handbrake still stays on because it is in the active mode. And so when does the active mode when does it go into the active mode? Well, we can just actually let this car now come to a rest all by itself in a natural manner. And we can see there up in the top left corner that it said inactive to active due to sticky tires. And now we come back to that sticky tire idea, because I've actually made it possible to query for that sticky tire state. So if the Physics vehicle SDK decides that we better enable sticky tires because this vehicle is almost completely stationary, then the handbrake controller can now react to that and actually enable handbrake. Now when I start moving again, it goes from active to inactive. You can see it twice because it's once on the client and once on the server. And again, if we let it come to a halt, it will go to inactive to active due to sticky tires. Hey Cactus, welcome back. Welcome back for some more game dev fun. Just started streaming, so you're right on time. And of course, the other option is to quite simply just hold the handbrake. It goes from inactive to active by input, and then it just goes from active by input to active. So if you hold the handbrake for long enough, it will actually activate and then stay on. So you can let go of the button. So I'm pressing the button, goes to active, and now I'm lifting the button. And we can see there in the HUD the HUD also reacts to that now, and that's actually where we're gonna pick up the work and continue working on this thing today, is in the HUD area. So that's pretty cool. It should be much more kind of robust now, this whole system. Much more sort of predictable when you have handbrake on and when you don't have handbrake on. And if you have enabled handbrake for a vehicle, it will actually not be disengaged by someone else nudging the vehicle or something like that. And vehicles all by themselves, they do activate handbrake if they come to a stop, whether or not there is an actual sort of driver in the vehicle. So that's pretty cool. So let's actually disable this debug print. And we can come back here. So now we got rid of most of that output, but not all of it. You can still see that HUD stuff there. So what's that about? Well, it is essentially the same thing, it's just filtered slightly. Or it looks a little different, and it also reacts to you essentially becoming a vehicle or losing access to a vehicle. So if I quite simply just destroy this game object here, we can see that the last HUD update here is inactive. And when we create a new vehicle, like that, oh, let's not block the writing to that. Right, when we create a new vehicle and we make it our avatar, then it becomes active again. And so the idea there is that you can actually use that state directly to drive the HUD. So when we switch between these two, you actually get, first you get an inactive and then you get an active. And so the inactive is the fact that you're essentially sort of leaving the vehicle, conceptually. And we're switching between these two guys here. We're essentially sort of like opening the door, leaving one vehicle, running over to the other one, and entering it, right? So the first inactive there is like, okay, let's remove the handbrake status from the HUD, if that makes sense. And then the active is the fact that, okay, we've entered the other one and it happened to have handbrake on, right? That's kind of the idea. So if we take this guy and we drive it slowly enough, this thing has so much inertia that it just keeps rolling here. Now if we switch to the other one, now we can see that the handbrake is active because we're in the Scout and the Scout has handbrake. If we switch to the other one, you can see that it is inactive now. So it would have quite simply removed that thing from the HUD. All that to say, we're gonna do some handbrake indicators and add them to the HUD today. Now I haven't done any HUD programming in a long while, so it'll be interesting to see how much of it I remember. But we'll figure it out, I think. So I think we'll probably add like a handbrake indicator somewhere here. I don't know exactly where it's gonna go. Maybe here on top of this. Somewhere here, maybe. I think that will probably look pretty alright. And actually I have prepared some graphics for this already. So here we have the sort of work affinity design, affinity designer. Yes, just made sure I remember the name correctly. Most of the HUD elements here have sort of like an element here. So I have like switch icon there, and some of these prompts of the radio menu, and the gauge and everything. And I created some handbrake icons for us here. I'm not exactly sure which one of these we're gonna use yet, but I'm thinking maybe these three. Alternatively, these two, and then this one. So if we use these three, my thinking was that we would show this thing whenever you are in the active by input mode. And that's just to make it clear what is actually happening here, so that if you're driving around and you engage the handbrake, it would sort of show here in the HUD. Okay, the handbrake is on. And then when it goes into the active mode, where it actually kind of stays on without going off again, it would turn red and possibly even start sort of glowing a little bit. And when it's inactive, it quite simply just goes away. That was my thinking. And so these guys are actually vector graphics. So they're made up of individual pieces here. And so we need to export these into a format that the game can read. And that's also going to be interesting. Because like I said, I haven't done any of this in a long while. Is it possible that I've managed to make these? Oh, that's just the... Okay, yeah, no, never mind. That's just the bounding box, of course. So here we have the actual so-called slices, specifying like the different areas to export. And we're going to export them as SVG files, I think. But we can take a look here at something else that looks a little similar. It's not quite the same, but it's a little similar. So it's this switch symbol which appears here when you are sort of close enough to another vehicle that you can actually switch to it. So if you put down a gripper truck here, it's a bit larger than I remember. If you're close enough to a vehicle and both you and that other vehicle is traveling slowly enough or is completely stationary, you can switch to it. And you can switch to essentially like the closest one. So we have this indicator here showing you which one you're actually going to switch to if you press the Y button on the controller and all of that. So it's a little similar in the sense that we show and hide one of these guys. It does move around, of course, like this, kind of follows the vehicle where it is. So we don't need to concern ourselves with that, because we're not gonna be moving this handbrake symbol around at all. But other than that, it actually is kind of similar. So how does this thing work? And should we just use that? I don't remember. I'm gonna have to see how that worked. So let's go to means data and start by going here into game and UI and scripts, and we have the HUD view. So the view is essentially populated from a script like this. We can create a bunch of different widgets. I don't unfortunately have any auto completion for this, so I kind of need to quite simply just remember how to do this. But I think we can always look up the bound functions from the code if you can't remember them. But basically the idea is that most of these things create something called a canvas, and you give it a name, and then from the code you can actually refer to that thing. But you don't necessarily need to put any code there at all if you don't want to. You can also quite simply create an image. Let's see some other. There's an image box actually. Yeah, here we go. Switch a vehicle marker. All right, so this is the exact one that we were talking about. And I don't think we necessarily need to. Yeah, it actually doesn't even have a name, this thing, so we don't need to refer to it from code at all. We quite simply create an image box. We give it an unstretched width. Okay, so it's unstretched. It basically means like don't stretch it vertically or horizontally, and give it this width. So it's like 1 would be the whole screen. 0.025 is like 2.5% of the whole screen. Essentially, this should actually all be hot reloadable. So let's see if it is. I'm a little scared because I haven't done any of this UI stuff in ages. But if we minimize this, or we make it smaller rather, and we take this, what was it? This guy. So it's this thing here. If we make it like larger, boom, there you can see it actually is larger now. We can make it like really large. Really large. That sort of thing. And since these things are actually because they are vector graphics, you can make them essentially as large as possible. They will stay super sharp. Never go blurry or pixely. Because they're just rendered at whatever size you want them to be. So that's pretty cool. So we should actually be able to create one of these guys. And here we can see that we are binding the visibility to a property. A property called HUD switch vehicle marker visible. And we are also binding the position to a property with the center as the pivot. So essentially what the code here is doing is it is setting this property with this name to true or false to make it show or hide, and then we're setting this property probably as a vector 2, so 2D vector, where to actually show it on the screen, and that is how it is kind of moving around like this when you're turning your camera and whatnot. So essentially what we can do is we can create let's say 2 of those parking meter images. One which is this, and another which is this. And then we just have 1 or perhaps 2, depending on how flexible I made that system, I don't remember anymore. Perhaps we have 2 properties that quite simply toggle them on and off. That might be enough to have it show. Then if we want to make it glow, that is a bit more tricky, and that actually has to do with this. This is not supposed to be like a black version. This is just something that we can, if we want to, we can export to a font, to a special HUD symbol font. You can see there is a little bit of glow around this number 1 here. That's the gear. And the glow, whichever the current gear is, it glows a little bit. It's kind of subtle because I don't want it to be super annoying. But these texts here have a little bit of glow around them. And it is specifically easy to do glow for text with this UI system of mine. That has to do with the fact that I'm using NanoVG for rendering, and NanoVG enables blurring text quite easily. So that's why we can blur that. Can't actually blur any vector graphics as far as I remember. but you can blur text. And so if you want to have a symbol that essentially glows, and you can see some glow here on the highlighted menu item as well. So if you want to have a symbol that glows, you can do it with a little bit of a hack, which I might be able to show you here. If we go to the demo mission, let's see, oh, don't I have it here? Load test mission, there we go. So this is a test mission for verifying the functionality of the mission system. And quite soon we will get a mission marker. It's going to show up around there. And again, it might be a little difficult to see, but there is a little bit of a glow around that marker. You can see it better if I put it here against this dark side of the car here. There's a little bit of glow happening here. And that glow is essentially me rendering. Hello. Would you want to respond, please? That glow is essentially me rendering this thing as a font, the custom font, just on top of this guy. Right? So it's a little bit of a hack, admittedly, but I think it looks pretty good. It's a very easy way to get a glow going. So this is the mission marker. It's not really used in the campaign yet. I don't really know if I want to have it or if I want the player just to have to sort of figure things out on their own. But I do have a mission marker there if I need it. Hey Poseidon, welcome back. Welcome back for some more. Right, so this test mission you can just quite simply... Hey, you found the place. And then the mission is complete. It is that simple. Anyway, so if we want to glow, we're gonna need to actually do a bit more work. Might be pretty nice to have the glow though. But if we do want to have the glow, then I think we're not gonna go with the whole create two images and just show them on the screen idea. Instead, I will actually create a UI control here in code, and that way we can actually just render it ourselves on a canvas. So this is an image box, this thing that we looked at, the switch vehicle marker, an image box, but most of these other things are actually canvases, which means that you get to draw into them using code. CodeResG says, hey, what are you using Unity? I am not using Unity. I have my own game engine that I am using. No Unity here. And so let's say we actually want to have the mission guidance. So here we go, mission guidance, HUD mission guidance canvas. All right. We create a canvas with a name. We set the position to, I don't know what that is. Let's see, mission guidance aspect ratio, and then width. So we have an aspect ratio of the mission guidance symbol, which would be this thing here. I wonder why it is like this. Oh, that's mission guidance. Sorry, that's not the one actually we want. Is it mission marker maybe? Yeah, mission guidance is actually like that's like this thing here. That thing. That's the mission guidance thing. What we want is the objective marker. Objective marker is the name. we have that here somewhere. Objective marker, yes, it is here. Right, so we're creating a canvas. I think the size doesn't exactly matter. You can use it if you want to, but you can actually just draw outside of the canvas if you don't really care. The canvas can be very useful if you want to sort of like bind the size to a property or something, and then kind of have the code just go like, hey, fill this whole thing, fill the whole canvas, and then it will sort of be the correct size. But I think in this case where we're doing like 1% of the whole screen, that is not going to be enough to show this thing, so I'll probably just draw outside the canvas, which is completely fine in this UI system. And then with pos 0, 0, that would place it in the center of the screen, and then the pivot is also center. So that would be placed in the center of the screen, and this center of this guy is the pivot. So we can do something like this if we want to. We can do HUD handbrake indicator, right? And you know what? Let's start simple. I'm gonna comment this out because we're gonna want it in a little bit. But let's start out with this thing, just that we get the sort of position going. So we create another image box. We don't really need to give it any sort of name or anything, and we don't need to bind these things to anything either. But I'm gonna set the position, and I'm gonna set the position to something like if we want to put it above this somewhere here, I'm gonna set the position to something like 0. That actually needs to be negative, right? I think. Where is the gauge? There's the gauge. Oh, okay. Okay, 0 is actually probably here up in the top left corner. I don't remember how these things work anymore. So, yeah, something like that. 0.04 and then 89. Cool. So let's go with, since we're using the center here, let's go with 0.1 and 75. And look at where that takes us. Then we need to actually have this bin SVG. So what would that be? Well, that is just quite simply an SVG file that I've converted into my special little format. Let's go back here and see what we have. So we have HUD, and we have all of these things as SVG files. So for example, we have the vehicle switch marker is an SVG file that looks like this. That's cool. Okay. So that is where we want to actually export it. Yes. Good. Okay. So we're gonna call this parking brake white, and parking brake glow. Just like they actually are named here already. And we're gonna make them SVG for export. And export them into means, no, it's not means, it's game UI HUD. So export them there. Get the next one. Export white, and then the glow. And so the glow is sort of like a mask, essentially. But rather than being like a black and white mask, it is sort of like a black and transparent mask. Specifically because we are going to turn it into a font later on. So here's the red one, looks pretty good. they need to basically sit on top of each other. Do they do that? They don't quite do that. We can sort of toggle between some of these guys, I think. Maybe not even that. That's a little annoying. Let's see, what do we have? What do we have here with this? They do actually look like they are a little stupidly aligned here. Let's try to align them better. So if I take that guy, that's parking brake white, and I align it with this one. Can I not do that? What is going on? The glow one is perhaps not as important, but it is still pretty good to have properly aligned as well. Let's move it off to the side, like so. Oh, does the white one have? Almost looks like it has like a shadow there. Oh, you know, I probably actually duplicated that by accident. Whoops. So that's parking brake white. Let's move it up on top of that guy exactly, and then move it to the side exactly like that. That's good. I'm gonna move this guy up to sit exactly on that one, and then move it to the side as well. Something like that. And now we need to come on, move this thing. Can I not move it? Sometimes I feel like this export pipeline of this program is a little wonky. I'm sure it's just a skill issue, but still, it does somehow feel a little wonky sometimes. Now that needs to be moved more to the side, I think. Something like that maybe. Let's try to export these guys again. Oh, damn. I made them in the wrong order. Oh, man. Made them the wrong order. So parking brake white and move to the side. There we go. Move up. And to the side. Yeah. This shouldn't take very long. I'll try to be quick here with this. You can actually even see here by eye that this thing is like further apart from this edge here than the other one. Oh man. There we go, that looks good. Now let's try this again. Parking brake, yes. Parking brake white. Make sure we have those two first of all. So parking brake is that one. Parking brake white is that one. Right, the white one needs to go ever so slightly to the left. That one. Ever so slightly to the left. We're actually cutting it off there. That's annoying. Yeah, the thing is though that we are actually cutting this thing off here, so that's not good. Let's not do that. Let's move this a little to the right instead. So that should probably do it. Yes. Yeah. That's good. We need to reopen those two guys. Yeah, I think I want to tweak this like one last time. Yeah. Let's go. All right, there we go. So now we have the two of them on top of each other, so to speak. So if we draw them in the same place, the only thing that kind of changes is the color of that middle section there. But we can of course make some other changes if we want to. What about the glow though? Which, like I said, isn't really all that. Doesn't need to be that exact because we're gonna blur it like crazy. Yeah, I think that looks positively wonderful, doesn't it? Yeah, that's just absolutely perfect. Cool. Okay. So, thank you for that. Let's minimize that. Actually, we can probably just close it. So now then, you can see that, hey, we actually already have these bin SVG files here ready to go, because we've been exporting them into the work folder root. So the converter just picks them up, and it's done it a few times here because we've been updating them a few times. So let's create an image box, and unstretched with width is probably fine. Yes, might want to make it maybe a little larger than that though. Let's try like 0.4 or something. And let's just get one of these guys. Doesn't really matter which one. Maybe just parking brake, copy that, and put it here. So now if we run the game, with a little bit of luck, we should have. Hey, there's our parking brake. Right, it's a bit large, and it's not exactly in the wrong. It's not exactly in the right position. I think this particular view is set up with a piece of code which actually doesn't auto update. If we move that thing around, you need to switch vehicle for the gauge to kind of appear again. Maybe just pressing Q here actually works. Let's try. But if I move that to the side, so 0.8, I think this thing is gonna go away. Yes. Then we need to switch vehicle to get it to come back. Well, that's fine. So the size is a bit too large. Let's make it smaller and move it to the side again, and a bit upwards as well, I think. Something like that. We are also missing a P, so that's a little strange. That might have something to do with the conversion, or that how that particular shape is actually is actually converted. But yeah, I think I kind of like the position now for that. We can see that we can fit the vehicle control menu there below it quite nicely. And if we want more icons, we can sort of put them there above this. Now it is of course showing all the time. That's not the idea. White. You can switch to the other one. It also lacks the P. So that's clearly something that's going wrong there in the conversion. But that's something that I just have to fix. Every now and then when I do these SVG things. Oh, you know what it is? I know what it is. We quite simply need to convert that to a path, right? It's probably actually, if we go and have a look here. So parking brake, there's this P, letter P here. We open that in like Sublime text here. We can probably find the P, right? Yes, it is that thing. So my bin SVG images don't support text. Like you can draw text in the HUD, obviously, as you can see here, and you know, it is dynamic and everything. But it needs to be drawn as text specifically. If you're drawing in an SVG image, it only supports Bezier curves, because that is the only thing that I've bothered to implement. And that just means that we need to convert that to curves there in the program. That shouldn't be a problem at all. So we're gonna do that, but I'm gonna go get a glass of water. I'll be right back. Rightio. So let's see here. Recent hard work. So this is essentially a text field. We can just go like hello, but we don't want that. We instead want to turn it into convert to curves. Now we can see that it is made up of curves, and we can even modify this like blip, like that if we want to, which of course we also don't want. And that thing should also be convert to curves, and that thing should be convert to curves, as well as that guy. Up, come on. Convert to curves. There we go. Let's see, we have some questions. Ernesto says, hello, love your work. Thank you very much. Seeing my work in progress. Whips. I have a question. So you think it is wise to learn to program in C++, Jai or Zig from the get-go, even if it's arduous? Or do you think it's better to ease it with other languages? I don't know. I don't know if it's that much more difficult. Like I wouldn't necessarily start with C++ in this day and age. Depends on what you want to do. But let's say that you want to do game development, because that's my field, and so that's kind of what I know. But I'm an artist mainly, but I admire the work of Jonathan Bloke's Moratorium and Animal West Dev. Yeah, okay, so it kind of seems like you want to get into game dev. So if you're an artist, I wouldn't necessarily bother with C++, at least right now, unless you get super excited about programming. It definitely opens a lot of doors to be able to use C++. I'm not necessarily talking about career opportunities, although that is of course also a thing. But I'm just talking about the fact that like there are a lot of things that you can do with C++. Like you can use Unreal with C++. You can also use libraries like I do, Physics for example, which drives my vehicle physics here. It's also C++, so I wouldn't really be able to use Physics probably if I didn't know C++. And so it's definitely worth learning C++, but I wouldn't necessarily start with it. Whether or not you actually want to become a programmer, but especially if you're more on the art side. And you were asking if you should do Jai or Zig or C++ or something compared to something else. I don't know what that something else would be. Like if you're talking about like the supposedly easier languages like Python or Lua or I don't know, C# maybe, something like that. I don't think it is that much more difficult to learn something like Jai or Zig or maybe Odin or something like that. Go maybe even, though probably not Go if you're serious about game development, at least on the front end. But like Zig or Jai or Odin are probably all good first candidates. Of course, I haven't really done anything except Zig out of those three, so I can't really say, but I have a feeling that they would all be pretty good options. Okay, so now that we have that saved as curves, we can do re-export. We save the white one, and we save the glow one. And that's that. I think we can probably just close that again. And now we can see that this thing updated. Now we have our letter here. It's just a path. There's no references to any fonts or anything anymore. Right, where was the script? So now if we go to that one, hey, there's the P, letter P. And if we go back to white, there's the letter white. And again, we can make this as ridiculously large as we want. Burp. It will stay nice and sharp regardless. So that's kind of cool. All right. What is... Oh, I probably paused the game, didn't I? No? Don't know exactly what is happening here. Almost as if okay, I had the game paused. Yeah, there was a debug pause going on. That's what confused me. But okay, I think the symbol might be a little large. That's a little large, so let's bring it down. Let's bring the size down. 100 with width, maybe 0.2. Is that better? That's probably better. And then do the red one. And then switch. Yeah, you can see the red one there is it's a little difficult to read, especially like against this pretty bright terrain here. It's much easier to read against something that's kind of darker. Are you using something that renders SVGs? Yes, I am. I am quite simply render them as curves. And I'm using Nano VG to do the actual rendering. So Nano VG is responsible for rendering all of my UI. So fair warning, this project is not actively maintained. I like this thing because it's so ridiculously small. NanoVG is a small anti-aliased vector graphics rendering library for OpenGL. Well, I don't use OpenGL. I've just written a backend for my own game engine. But yeah, it does all kinds of things. It does like these animations that you can see when we go into the pause menu, and renders essentially everything except these debug texts and things. And they're essentially all SVGs. Although the game doesn't actually read SVGs. I have kind of like my own format for that, which is sort of like a byte code. But the idea is the same, that you're rendering you are rendering vector shapes. Okay, so I'm not super sold on this visual here. We can maybe go to another level. Let's go to the depot level, for example. Which also has a pretty where's depot? There's depot. You should write your own UI framework on top of NVRHI. That is exact. Oh no, not NVRHI. NVRHI is just the graphics abstraction. Yeah, you don't want to write it just on top of that if you're not, you know, if you don't like writing lots of vector math, then sure you can do that. Of course, NVRHI is what is rendering everything in the end, right? Like we added this SVG. We added this SVG image here, right? The SVG image has quite a long way to go before it ends up on the screen. First, it becomes this. This is just standard SVG stuff. This is fed to my converter. So here we can see goofy SVG converter. This guy takes the SVG, reads it out of that XML data, and it converts it into my own format, which is, let's see, where's the SVG data is right here. So the SVG data it is sort of like a byte code. So it has an opcode, begin paint, stroke color, blah blah blah, move to Bezier to line cap, fill and stroke, and all of that stuff. And then it adds it into this guy. And then we have something called an SVG image, which we can render SVG data. And here it quite simply just iterates over all the commands. And here it converts it into Nano VG form. So Nano VG was the library that we just looked at. So NVG, these things begin with NVG. They are Nano VG commands, right? So you can do fill color, for example, or you can do Bezier to or move to. And then these guys go into the NanoVG, which is, what is this? 3000 lines of C, essentially, to render it nicely and anti-aliased. And then go into Goofy, source, and where is it? Where's the thing that I'm thinking about? Here we go. NanoVG GFX API. So here's where NVRHI comes into play. So this is a backend for NanoVG, which is another 1,600 lines. So it's not super tricky, super large. But here, for example, we have render stroke, right? And this is something that the NanoVG calls, and it allocates a bunch of things, and then it renders them. So render triangles. Somewhere here we have the actual draw call. Let's see, where is it? Set graphic state, draw shapes. Here we go. There we go. Context command list, draw indexed. So this is in NanoVG fill when you're filling a shape, and this command list is an NVRHI command list. And so all of this happens to this little guy here. Same as this gauge, same as this post menu screen and everything. All goes through the same thing. And in the end, we are in fact going into NVRHI. So here we are in NVRHI.h. So it is of course sitting on top of NVRHI, no doubt. Okay. Anyway, you can see here that kind of doesn't really work with that red one. We might have to tweak the color of the red one, and we might have to add that glow there to make it really readable. I think the white one was a lot better in that sense. So go here, and we add the white one back. So you can see the white one is very readable. Doesn't really matter what is behind it. It just works. So that's neat. And I think that just means that we, like I said, we need to add that glow there to make it sort of look like it's almost like a well, like an indicator on a dashboard that sort of turns on, starts glowing a little bit. But yeah, the white one works. So let's start hooking this into the code. Let's start making it so that these different versions show up at the correct place, and then we can make the red one look nice and beautiful. How about that? Boink. Do you plan to make the engine open source at some point? Probably not, but I will not open source, but I will make available a pretty significant part of the game's source code for modding. And so that also opens up a large part of the engine code. So essentially everything that we have here, source, basis. So basis here has just a whole bunch of things that you can use to create, well, content, essentially. So physics, for example. All of this stuff will be available to you. I'm not using the term open source because it won't be open source. It will be source available. But yeah, you will be able to to use it to create stuff. The engine itself, probably not. There's just like a whole bunch of reasons for that. First of all, I don't really think there's a market for this engine in today's day and age. Like it would be a significant piece of work for me to open source the engine for very little gain, so to speak. Second, I actually use some third-party code that I am not allowed to release on the tools side, not on the runtime side, but on the tools side. So if we're looking at like, you know, like this audio editor here, for example, if I was to open source the engine, then of course I should also open source this audio editor here. And I think this thing here, for example, uses like a third-party component that I am actually not allowed to share with you, because I bought it myself to be able to create this program, but I'm not allowed to share it. What did you use for sound? Oh, well, I just happened to show this. Yes, I have implemented this thing. It runs on top of... well, here you can see I did some research on parking symbols. So Loud is a library. So I just search for So Loud. This is the library that plays back the actual audio. It's very nice. It does like all the virtual voice handling and 3D audio and all of that mixing. But then I have this sort of thing on top of it, which is something that I've showed off previously, but I can do a quick retelling here. Let's go to the dev project and let's turn off the music for a bit here, so we can hear some stuff. So it's a node-based thing. You create these kinds of events that you can then start and kind of modify from the game. So if we play this, you can see that we now quite simply we start here and we play an audio, and the audio is an MP3 file that comes from there, and we can stop that. So here we have another thing. This is just like a test project that I'm using to you know, test out the system. So let's maybe turn down the volume a little bit. Okay, stop. Some more. I'm just turning it down here from the actual event properties. There we go. So we have a piece of music here. We have some parameters, so you can do like all kinds of like fun little parameters, and then the game can adjust these. I have a distortion one, which we will be very careful with. Because as you can hear, it just blows out the audio quite a bit. I have some high pass filters here. All kinds of fun little things that we can mess around with. Seek speed test. Yeah, and here I actually have like a parameter for the volume, so I can just pull it down like this. And this is kind of like, it's inspired by the Unreal Meta Sounds system. I kind of wanted Unreal Meta Sounds, but I couldn't quite do that. So I did something like this instead. But for example, it's pretty handy to have this, because I can do the, if we go back to the actual game project, we have the so far only engine sound, which is here. And we can actually, let's bump up the volume here a little bit. So here we can just, the game like adjusts this RPM parameter. Like this. And you can see that it actually kind of, it mixes a whole bunch of different files together to make the final sort of output. Alright, sorry about that. I'll take a quick phone call. Some other things that we can do is, see this one. So here's a com radio menu sound effect, which you can send 2 signals to. So you can send open, and it randomly selects one of the sounds to use. And then there's also a close one, which you know, when you give a command to one of the cars, the game sends this close signal to the actual to the running event, and it can go in and randomly pick things from that. What is this? Yeah, that's some test that I don't think I've ever actually really used. Yeah, here's like the sound that when you insert and pull things out of a power cell receptacle, it can just randomly select things. Stuff like that. It's pretty fun. Here's the ambient loop for the demo level. It just plays a whole bunch of different things with some random chance. It's actually pretty low in volume, I think, but you can kind of hear some things happening. But yeah, that's the audio system. You made your own audio engine or something? Yeah, something like that. Something like that, indeed. Indeed-yo. Oh yeah, here's a pretty fun one. Though this actually requires some speech, but I think we can look at it in the other project. I had some speech here. So I was thinking like, okay, how do we... It's called maybe radio test? Yeah. Radio test. How do we actually take a piece of audio and make it sound like it's being played back over a radio? So I think I have, quite simply, let's take a play audio node and copy it here. Just play this piece of this piece of speech here. Ground control to Major Tom. Oh. Commencing countdown. Engines on. No input to audio source node. That's not good. Because it's self-made. So there's some jankiness to be expected. Yeah, right. Okay. Yeah. Okay. That's the problem. Let's take this guy again here. I'm gonna disconnect those two. So we have a wave asset, and we plug it into here, and in on start we just hook that to there. So now if we play this, ground control to Major Tom, commencing countdown, engines on. So that's just a piece of sort of test dialogue that I recorded. Ground control to Major Tom, commencing countdown, engines on. And then if we hook it into this whole monster of a node here, it sounds like this. Ground control to Major Tom, commencing countdown, engines on. So you can just you can take one of these guys and plug it into there. This is a second line of dialogue to be played back using the radio effect. So that's pretty cool. I plan to use this for the communication between the vehicles in the game. Okay. Anyway, let's keep going with the handbrake thing. How to make sounds play? I did not make my own backend. No, I showed this a second ago, but here we go once more. So loud is the audio sort of playback and mixing library that I use. This guy is actually not even the thing that plays the audio. This guy has backends. So you can see here in the quick start we have a whole bunch of different backends that it supports. Among others, it supports to open AL, but I'm using the mini audio one. But yeah, that is what plays the actual audio. Anyway, let's keep going. So, what I need to do now is I need to create a HUD control for this. And we're going to do that in the game code, unsurprisingly. So we're going to go here, and we're going to go and have a look in the UI. So we have the objective marker, I think, might be perhaps the closest. So there's a render function that we can use to quite simply just draw the image. And drawing the image is very simple. You need to just have an image and you render it unstretched at some position and with a pivot. And then we have the whole glow, symbol font glow, which we can use for the handbrake stuff as well. But let's copy this guy and turn it into HUD handbrake indicator. All right, I'm just looking at what we have here actually. So we have a vector 2. I don't know if we're actually going to need that. NanoVG is like a wrapper for, or NVG is a wrapper for the NanoVG stuff so that we can render. Symbol font glow, I think we're going to leave this here, but we're going to set it to false for the time being because we don't have the glow working yet. Yep, we have a renderer pointer, we have a canvas pointer, we have an SVG image, so we're going to need actually I'm gonna need two of them. We're gonna need the image for the white one and the image for the regular one, the red one. And then symbol font handle. We can get all of this actually from the, well, all of this stuff can essentially stay. We just need to update these names and paths. That's cool. Right. Let's keep going. So parking brake, that would be the main one, right? Parking brake bin SVG. And then we have image white. Image white. And that's essentially the same as this. Parking brake white. And right. Right. Now we can't use this image box anymore. Instead, what we want to have here is the handbrake indicator canvas. So we're going to want to get a pointer to the handbrake indicator canvas, like so. But I think the position can probably be the same. So I'm going to take this guy and move it here. And maybe we can use the same size as well. I don't know actually. Let's just keep it as it is because it kind of doesn't really matter all that much. All right, and we need to, of course, do that. And then we need to do this. Get rid of both those. Oh, I need to turn the music back on. Like so. Guys, while I am very supportive of your discussions there in the chat, let's keep it in English so that everyone can understand what's going on. I might not have that much time to look at the chat right now, but let's share the knowledge with everyone. That's been sort of a rule that I've had for these things, both on the Discord and on here. Let's keep it in English, unless you do like private messages, in which case you're of course free to talk about whatever and in whichever language. Okay, so we don't need to mess around with the position at all. We do, however, now let's see, canvas. What do we need? Camera. We need the camera to calculate the position, but we don't actually need the camera here. Instead, what we will want to have is the state, right? The state would be means.handbrakecontroller.state. We're just chit-chatting, not important. That's completely fine. That's completely fine. However, it might not look like that to other people, so nothing against Turkish, of course. But I kind of like, even though people sometimes write to me in Finnish or Swedish even, because I speak both of those languages, I kind of just tend to respond in English and go like, this person asked me this and that, and then I just answer them in English and make it very clear that like I do it so that everyone understands and gets to take part. But hey, no problem. All right, so we can just get rid of the calculate position. We don't need that. And I think I'm just gonna comment that thing out for now. And we can let those be. It's fine. So we're gonna want to hold on to that state. So handbrake state. That would be means dot handbrake controller state. And that is actually, you can set it to actually not active but inactive, right? After declaration, yeah, right. It needs to be like so. See you later. I have to go for dinner. Have a good dinner and thanks for hanging out. Right, so here we basically do switch handbrake state, and we do active, and then we do something. Active by input is something else, and we essentially need to have an else here, but I'm just gonna list them all and Zig will be happy with that as well. So if we have an active, we're gonna want to render the image. If we are active by input, we're gonna want to render image white. Canvas based position width is that. Did you know Cube 2 Sauerbraten? I do know it. I haven't played it, but I do know of it. I use eNet for the networking here. So eNet networking, and I think this thing was originally actually made for. Oh, their website is down. Wasn't this made for Cube originally? That's not the one I want actually. It's this one. But I'm not sure it actually is listed here. Cube. Yeah, ENet evolved specifically as a UDP networking layer for the multiplayer first-person shooter Cube. Here we go. And so I think Cube 2 Sauerbraten also uses this. And that is what I use for my networking. So I know of the game, but I haven't played it. But yeah, as I understand it, it is a fine game. Right, so state here, we need to set this to G. Handbrake state is state. Like so. And maybe what we could even do is, based on the state, we can do if state is inactive, then we set the canvas to visible to false. Actually, we can do it like this. We set it visible if it is not inactive, right? Hide. What do we need this visible thing for? Probably not really anything, right? Yeah, I'm gonna take that away. I don't think we need this for anything. Hide as well. And then this render thing here is going to get called if it is visible. So we get the canvas hot handbrake indicator, and we assert that it's not null. Then we store it and we set it to be not visible, and then we set the render callback to be that function, this thing here. Just turning off my air conditioning here. It's a bit unnecessarily cold. Rightio, and now we should essentially get the correct icon rendered there for us. Should be good. But of course we still need to call this guy. And I think we can call it from the in-game UI view model. Actually, it's probably in the HUD view, is it? No, might not actually be. Let's see, HUD objective marker. Yeah, okay. Yeah, this looks good. So, essentially, we just import that HUD, that new file here. Let's do HUD handbrake indicator and import like so. And then what we want to do is we want to initialize this guy. So init g client allocator and g HUD view. Do we actually need the allocator for anything here? Not 100% sure. We just need the client, right? Yes, exactly. And then here we need to do the opposite thing. How do you debug shader code? Do you use RenderDoc? I very much use RenderDoc. RenderDoc is a godsend. Yes, RenderDoc is the best. It's the absolute best, and I use it a lot. Let's actually not call that. Let's call it set handbrake state instead, like so. I don't have a whole lot of shader debugging functionality in the engine, so I mostly rely on things like RenderDoc for debugging my shaders. Yeah. Trying to think if I have something worth mentioning here. Oh. Let's see. State, like so. So here's that HUD handbrake now X that we saw there earlier. We can just get rid of that. Oh, yeah, that's not how I wrote it. All right, so what do we have? Look at that. Now it showed up. And now if I start driving this thing, the indicator should go away, and it does. And if I now hold the handbrake button, we should see the white one. White, and then it should turn red, and it does. Isn't that cool? And the red one still looks like ass. It's really not readable at all. So we need to do something about that. But still, it works. The logic works. That's neat. And now if we do the same thing again, where we drive here, like so, and then we make this sort of roll, and now we switch to the one that has handbrake on. We can see it appearing, and if we switch back, we can see it going away. just some edge case testing here, because those things are always the things that kind of break. And if I keep moving while I have the handbrake on, you can sort of see the white symbol appearing there while that is going on. And then when it comes to a halt, it becomes red, and that means that now it is active, and it will stay active and engaged even if I let go of the key. So I need to essentially start driving again for it to go away. Nice. Nice, nice, nice. Yeah, that's cool. Okay, so how do we now then make it glow? That is the question on everybody's mind, including mine. And the way I've done it with the mission marker is I have somewhere here HUD symbol font. So we have the objective marker SVG thing here as well. Let's copy that one thing, the glow, out of here and into there as well, so we have it sort of in the correct folder. HUD symbol font. We can open this HUD symbol font .bird font, and so bird font is a program that allows us to essentially design fonts. You can see that we have this font here which has all of these symbols. I essentially only have one symbol here for A, so we're gonna add this thing to the B, letter B here. So import SVG file, and we import not from there but from UI work HUD parking brake glow. Something like that, and we can see that, okay, we want to make it probably a little bit larger. How do I scale it? I haven't used this in like a year or so. How do I scale it? Is that scaling? That's probably scaling. Yep. Scalaroo. Not that. The entire thing. I'm not terribly good at using this thing, but I kind of manage. Maybe move it up a little bit. Something like that. It's kind of roughly the same size. Maybe we should make it even a little bit larger still. Something like that. I think that is kind of close enough. We're gonna have to fudge it a little bit. We're gonna have to basically offset it probably by some small amounts to make it look nice there on top of the actual SVG file, SVG image. So file, save as, is it, or is it export? Import export. So export fonts, yes. I don't remember it being this complicated, but let's see. HUD symbol font TTF. The TTF is the format that I've used. Font Mac. I don't think I care. Let's just take the Mac thing away from there. Export. What? how do you render the UI? I'll get to that in just a second. I'll try to get this working. So let's see, folder, HUD symbol font is right there, yeah. Right, okay, so that, used that incorrectly there. So it's, you need different names for the two font files in the export settings. One file is for Mac, that's, oh, that's why it's called Mac, okay. Okay then. Okay, and now it has updated it, okay. Alright, so, yeah, you can't really see the things here, but you can see them very sort of faintly here in the list of all the characters. Right. So let's hope that actually now works. I'm gonna save that and shut this down and go back here outside of the HUD, and the font needs to be copied here. This is where the engine can actually read it, and you can see that it has actually already picked it up. So that's cool. So how do you render the UI? For my game engine, I thought about using XML or HTML based render that renders basic UI. Will it be feasible? It will probably be feasible to use HTML. I don't know, like XML doesn't really have a render format per se. But of course SVG is actually XML based. I showed earlier here, so we exported this thing right from Affinity Designer, and this thing can now be seen there on the screen. So I showed earlier the sort of whole path that I take for rendering it, but the short of it is that I used a library called NanoVG, and so this is a small anti-aliased vector graphics rendering library for OpenGL. I don't use OpenGL, but I've created my own backend for it. I like this library because it is so very small and simple and has no dependencies almost. I say almost because it has like one, but it comes with that one. And that one is STB image and TrueType, I guess 2 technically, and then font stash, but that's made by the same guy who makes the actual library, so I don't know if it counts as a dependency, but anyway, this is everything you need. So it's essentially a single C file and a header, the library itself, and this renders the stuff as vectors. And so again, I showed this earlier, but we can look at this again too. Oh, I don't want to actually run it from here. Well, I guess we might as well. We have this icon here, and we can put back the other one that we had previously. So if you have this parking brake white thing here, we can just make this larger, like that, to make it ridiculously large, and it stays super crisp and nice. It never pixelates or becomes blurry or anything. And that's a nice thing about using like a vector rendering library to do UI. So I render all of this stuff with the same vector rendering library, and I can do animations, as you can see, with that sort of fade as it comes in. If we go to the menu, you can see a little bit of an animation here with the logo when it fades in. All of that stuff. And it's NanoVG. And so I basically take my XML, which, you know, these files are. So parking brake, this guy, looks like this. And this is of course XML. So I take this format here because it's not super efficient to be parsing XML at runtime, and I turn it into something that I call binary SVG, but it's a completely custom format. So that's why when we load these images at runtime, they're called bin SVG. And that's just it's a binary format, but it essentially contains it essentially contains the same commands, if you will, to render. So everything's based on SVGs, right? Isn't it costly to render? It's probably more costly than rendering raster images. Yeah. The way I do it is that I convert the SVG to a kind of bytecode. So here we have an SVG image in C++. And this guy takes something called SVG data. SVG data has some opcodes, just like, you know, any bytecode essentially. And here you have all of the commands that I support. And using these commands, I can render all the UI that I have currently. And then we would just add it to a vector of commands, and then you have a separate vector for paints. So paint is like, can contain like gradients and things like that. And then when we render the image, we go to render SVG data, and here we quite simply just have a for loop where we switch on the opcode, and then we do nanovg rendering commands. So begin path maps to nvg begin path, stroke color maps to nvg stroke color, and so on. And I guess like these two, so move to, Bezier to, fill, and the stroke ones, and I guess arguably begin path, are like the main ones. Then you have some more stuff here. Close path is obviously also important. And that's it. So yeah, I don't process the XML at runtime. I just do this. And I think this dump command just evaluates to nothing. So yeah, it's probably not the fastest, but it's never showed up in any of my profilers or anything like that. So it is fast enough, shall we say? All right. So now then, render symbol font glow. Let's just see what happens if we actually render this. Where's the color, by the way? It's this one, UI color HUD turquoise. Yeah, we don't want that. We want the red one. But let's see what happens. So essentially, we should be getting, if we are rendering the letter A, which I bet we are doing here. Let's see. Text. Objective marker glow. Yeah, that's the letter A. And we can see that it's objective marker glow. So if we go back to work and HUD symbol font, like A is this guy, and so B would be the one that we actually now want to use. Parking brake glow. So let's copy this and add it here, and we can do parking brake glow, and it's called parking brake glow, and it's the letter B, the capital letter B to be precise. So we take that and we put it here. And if we don't blur it, first of all, let's do it completely without any blur. We can see that it probably doesn't match up directly with the underlying image there, which we have just rendered here. And we can see here, it's pretty tricky to get the symbol glyph to line up perfectly with the underlying SVG graphics. Currently we do about tweaking these and still won't line up exactly in all cases. That doesn't really matter for glow effect, and that is just my sort of cop out there, that I couldn't get it to line up perfectly for the objective marker, but it doesn't matter, it really doesn't, because when it is a glow effect, it kind of just needs to be almost matching. Here we can see that, okay, it's kind of faint, but it is there. Actually, if we make this larger now, I think it should be easier for us to see it. Let's make it like quite a bit larger, actually. Oh. All right, that's not the correct one. Yeah, that one actually needs to just go away. Bye-bye. This is the thing that I want. Yeah, there we go. So this is now the font. Okay. But we're not rendering the actual icon with that. But that's fine. That's completely fine. I think we need to make it slightly smaller. I'm going to move this off to the side just to make it a bit easier on myself here. So font size, let's make that maybe 3.5. And it is a little, let's see. Yeah, it needs to be, actually let's just try with that. I can leave the same comment there. I've only ever done this in one place, and this is not the second time I do it. You can see that, okay, we're getting pretty close, but we need to move it a bit to the left. And yeah, doing this immediate mode tweaks is not ideal currently because I don't have hot code reloading for Zig. That's getting pretty damn close, but it's not quite there yet. Let's do that maybe, and something like that. I don't know why I do the divisions there. Okay, that's a little too much. Too much up. So that's like times 0.5. We need it to be something like times 0.6 maybe. Yeah. Yep, it's very close now. 2.5 maybe. I don't know. Something like that. Now if we add the blur there. We're blurring it actually quite a lot. We get the blur effect, however, we don't have the correct color yet. Yeah, so it kind of doesn't really even show up currently, and that's fine. Let's add it here to active because that is the only time it's supposed to actually show up. And we can maybe blur it a little less. Let's do 8 times. And I'm gonna do fill color. What does that take? It takes just a basis color. Okay. So let's do NVG, fill color, context, and basis.color.red to start with. It's supposed to be color red. What do we actually have here? Let's see. Width. It would be nice if we could actually scale that, and we can scale it if we look at the size that we have here. Brake indicator 001. We're actually drawing the 002. Okay, so let's do const image width. That would be canvas base get size, right, x, and I think it's 10 times 2. That should be what we want. Yeah, look at that. Now it's actually like properly glowing. I mean, it doesn't look very good yet, but we can fix that. So now we can actually make this larger, I think. A whole lot larger. Yeah. Now we can see that okay, it's not quite matching the underlying thing there, but it's not like super far off. The blur is sort of in pixels though, if I remember correctly, which means that the blur will actually be way too sort of faint here when we scale it up by this much. That's not really here nor there. Let's bring it back down. And again, we need to tweak this to make it look neat. So if we now have the brake light indicator against something dark, you can see that it kind of looks like it's it looks pretty nice. It's basically what I'm trying to say here, or like against the sky there, or the like background color. Looks pretty neat here. It doesn't look very good. It's very difficult to read when it's against something lighter. So basically we need to make it brighter still. So what I'm gonna do is I'm gonna take the file that we had. Let's do recent hard work. And I'm going to bump up the light intensity for those red parts. So here, I don't know how much, but let's just try something. Let's do like an HLS or HSL rather, 62 to like 70 maybe. Let's try with 70. Yep. Should I maybe try just upping this glow color first? Maybe that would be a good thing. What would be the RGB values for this now? Just writing it down here, old style. 242 115 116. Let's try making the glow more intense first. Yeah. Actually, I can probably just do this and then init 242 115 116. I think I'm gonna change the music here. Something a little bit more maybe up tempo. All right, so that's brighter for sure, but it's not super bright still. Yeah, it's starting to look kind of nice against some of these things, but not all that nice against the really bright areas. So we're gonna have to bump that color. It can't be helped. So let's do that. Take parking brake and export it there. Yes. All right. Now it's really quite bright actually. Another thing that we could try, which might perhaps be an even better idea, is to make the background a bit more opaque, right? So let's try something like 30. I'm gonna go even higher and go to 35. Same thing for this. 35. And this one as well. So parking brake, yes. Let's start with that actually. So now we should see the background actually getting more dark as well. Yeah. It's definitely getting darker. Right. Yeah, that's already more readable. Not sure if it is quite as readable as it should be. This is kind of like, you know, a programmer trying to do graphic design. I think this is probably like pretty classical graphic design, trying to figure out what looks nice on a HUD. I'm liking the white one quite a lot. But I wonder if the round background maybe a good idea. Might be. All right, let's try this against some of those levels that we had going. We could even maybe make this even a bit brighter still. Let's go to 125 on both of those. And I'm gonna blast up that font blur some more. Kind of really make it shine. All right. Yeah, that looks better, I think. And now we can see that the glow is sort of reaching outside of the actual icon there, which is nice. I'm touching my backend table here with my cable. That's what that overlay is. So let's do actually refinery blockout. So the demo level. See what that takes us. All right. Parking brake and parking brake on. Yeah. I mean, it's alright. I'm not loving it. It is alright. So now we should have the same slightly darker background on both of those versions there. Like it kind of loses a little bit of its clarity, right? When it goes from white to red, which I guess makes sense. But still, it's a little annoying still. It's a little unreadable. So what if we now do the same thing here? We go here and we take icon and we bump this to 255, 125, 125, like so. Bump it even higher. Same as the glow now. And then maybe we can make the glow even higher if we need to. All in the interest of actually making it as visible as possible, as readable as possible. We actually like making it more or less readable with this glow here. I mean, it does get a little sort of muddy, I guess, with the glow, but that's to be expected because we are blurring it after all. Just like add even more power to the glow color. Yeah, I think I'm gonna probably have to, you know, think about this and sort of play with it a little bit. I mean, even more than I've already done today. Because like, you know, graphic design doesn't come to me very easily or naturally. It's something that I have to kind of chase. So might be that I have to try out a few things sort of over time, see what works and what doesn't. I guess it might also be kind of nice to sort of integrate that with the rest of the like, gauge and everything. It is kind of nice and informative now, like you can see it there, even though we have the vehicle controller menu open. You can essentially see it at all times. Right, so if we go here and we go to the mother vehicle, we can just switch here and go like, oh, okay, yeah, we have the parking brake on. We can just mess around with this. The vehicle is not going to start rolling away somewhere immediately. Just violently swing this around. The parking brake will stay on. Whee! I think with less blur and more whitish color it might look more readable. It does indeed. It does indeed. Right? That is essentially exactly what we're doing here. If we start backing up and then I hold, you can see now it's like the white one is definitely more readable before it turns red and starts glowing. Maybe you're onto something though. Maybe I just need to tone down the glow a little bit, maybe to half of what we have it now. How about that? For the debug error code, white outline, it might be more readable. The debug error code, what is that? I'm gonna just experiment with this a little bit, like see what happens if I make it almost not blurred at all. Yeah, now it's sort of close enough to not being blurred that it's actually sort of a little annoying because it doesn't line up with the underlying thing all that well. So let's not do that. Debugger output on the right bottom corner. Yeah, that one. I mean, you can just click that. It's not something that obviously it's gonna be visible to the player. Yeah, this thing. Well, first of all, it actually sort of fades away towards the top. So the most you can see that this is already sort of like semi-transparent here. It's just to show a little bit of like history. What can I do to actually print something there? Probably if I hold down this and like move this around a little bit. Yeah, now you can see time drift because I'm essentially like blocking the main loop. Then it reports a little bit of time drift between client and server. Now we can see that this thing is just like fading away towards the top. That's just there to like have it sort of fade away a little bit before it actually kind of completely disappears. So the really readable one is here towards the bottom. That's like a super old part of the engine. It's probably like 15 years old or something. Yeah, I do think we need more blur though, but we might need perhaps RGBA. What if I do this like 255? How's it gonna look? And then I'm trying to remember here exactly how opacity is to be given here with the text. I don't exactly remember that anymore. So now it's clearly visible. What if I now like pull this down to something like 50? Maybe better blur with sharp cutout. Well, the thing is that NanoVG supports exactly one type of blur. This is the thing that like comes with you know with using NanoVG, is that it is kind of basic. I agree, it's perhaps not the most beautiful blur that you've seen, but it works actually really well in some situations. Like I really like it on this gauge, for example. It looks really nice. What if we try something like this? Yeah, we don't want that anyway. So let's take that away. And we can comment that out to leave that color there for future use. And then we actually render the white one instead of that. So we render just the white one, but we render the white one with glow if it is in the active state. I'm just trying here, seeing what that looks like. So we can see that it's like it kind of turns on. And now it is at least kind of obvious, quite easily readable. So what if we now make the glow slightly redder, very slightly, something like that. It does look a little strange, but it's just basically like we have to tweak the color of the underlying image as well. Might just be that like we've had this too sort of dark the whole time. So icon 255, let's do 280, 280. This is kind of interesting. What if we make it yellowish? That kind of, is that cool? try that. Parking brake. What was the value for the blue? It's 128. So 180 and 128. Oh, 125, sorry. 125, yes. 180 and 125. I just got the red from the fact that like it tends to be red in actual real life cars, and it was red in the reference image that I had. Yeah. I'm not sure if it's like obvious enough that is what's going on there. But then again, it might be. If we're gonna go this route, let's make it maybe even more yellow. Something like that. 220. 220 and 80. 255, 220 and 80. And export that one. Parking brake, yes. Let's save that for later use if I want to. 220 and 80. And I'm gonna go up to 200 with the alpha. Alright, let's try that. Awesome work. Well, thank you. Thank you. Love your videos. That makes me very happy to hear. I have a question. How is your rendering architecture structured? I feel like that's the most difficult part of engine development. Very poorly. Very poorly. Yeah, like I've said in the past that like I'm not a rendering engineer. It's probably the only, at least kind of like the only part of game development that or like programming that I haven't done like professionally ever. Rendering, and it probably shows. I'm just tweaking these colors here. Let's go down to 140. And I'm gonna want to tone these things down again. I just don't like them when they're that dark. Yeah, so rendering is the one thing that I haven't done professionally ever, and so it's all a big hack. If I'm being honest. I can maybe take you on a tour through the renderer. 140 and 80, but I'm kind of worried you're not gonna like what you see. What you'll see. It's very basic. I don't do PBR, first of all. Some years ago, the renderer that I have would have probably been called something like the mobile renderer by Unity. Unity used to have this sort of concept of like mobile friendly renderers. They use like an old school non-PBR forward rendering sort of thing, and that is basically what I have. Nowadays, of course, almost every mobile device supports. Well, maybe I shouldn't say that, but like the mobile devices tend to support pretty standard rendering techniques these days. And the reason I don't have a PBR renderer is quite simply because I'm not very familiar with how that works. I kind of gotten the impression that like, you know, you don't need like a whole lot of info to actually make such a thing. You kind of just need to have like a GGX shader or something like that, and that is essentially the PBR for you. But I quite simply just haven't really made any games that would have kind of required that or targeted any sort of even semi-realistic look that I would really have wanted or needed, that kind of thing. Wanted is another thing. We're getting to a point here where I kind of want to try out another of my ideas that I have had with this. And that is using this exclamation mark for this white one, essentially. So if we take this thing here. Not that. No, not that one. Not that one. Handbrake. So like we have the P there on the parking brake. And so the idea was that like that this would specifically be, you know, the handbrake. The handbrake is kind of like what you have when the vehicle is still moving. I know that is not how it actually works. All right, it's a PNG. That's why I was wondering why don't I see my SVGs, but I need to set this to SVG. Handbrake. There we go. So handbrake is kind of like when you're skidding or sliding or something. You get this exclamation mark, and then when you are actually standing still, then it turns into a P for parking, and that might be, you know, another way to sort of let the player know that, hey, you're actually parked now, as opposed to just having handbrake on. You really cooked with that art style. I love it, not gonna lie. Excellent. I thank you for your kind words. It is coming together. Yeah. It is coming together. And of course here, like, a whole lot of this art style, I feel, comes from this this shell textured grass. It brings like a whole lot of kind of character to this whole thing. But the shell textured grass is kind of tricky to light, and so it is not perfectly lit in many cases, and I have to resort to some like pretty weird like SDF tricks, for example, to light the grass there underneath the car, for example. Uses like a sign distance function hack, because I kind of want the grass to sort of flow into the terrain. Kind of just look like it's kind of not even there until you get close enough and realize that, oh yeah, it is there. And then of course this area, this level is not light mapped yet. It tends to look a lot nicer when we get light mapping enabled for this. But yeah, I thank you for your kind words. It's fun to hear people liking this. Okay, so let's see here. Image white. Let's call this image active, I think. Right, it's not used there currently, but we're gonna make it now. Image active. I'm gonna take the glow away for now. Kind of a little bit disappointed in the glow. And then we're gonna call it image active by input, which is the other state. And active by input is gonna be rendered like so. So active by input is gonna be parking brake or handbrake rather, this guy. And active is going to be parking brake white. Anyways, I have to go. It's nice to knowing you. See ya. Well, thank you for hanging out, and welcome back maybe some other time. Have a good one. Yeah, I know this is perhaps not the most riveting of content. So we have the exclamation mark there when we are actually holding the brake, and then when we go into parking mode it turns into a P. Maybe that is the nicest version of all of this. The thing you do with RenderSync for editing is magic. It is absolutely. It's absolutely magic, and you should all do something similar for your respective projects. I think this is probably like the best version. So we're holding the key, and it is an exclamation point there, and then it just turns into a P when you're actually parked. I think that is, maybe that's even like the most sort of informative way, because it actually changes, the symbol actually changes. So now the question is, should we have it as white, or should we have it as something else? Maybe it should be white. It's not actually fully white. It's this kind of like off-white thing. But yeah, it's kind of neat. And we should be able to resize it without shutting down the game now. I'm just gonna bump the size here a little bit. Handbrake indicator. So if we make it like twice as big, twice as large. Now it's super large. Now it's super large. And that's way too large. But what if we make it somewhere in between? And that's still pretty large. Let's make it a bit smaller still. Yeah. That might be kind of nice. I don't know. Let's leave it like that for now. I think that'll probably do. It's gonna have to. I'm gonna have to sort of get used to that a little bit and see how well it fits. Because we don't have any super funky and weird sort of colors or anything like that now. Colors or shades. It's all kind of the standard ones that I tend to use in the HUD anyway. That's also very nice. So let's play a little bit. Let's go drive there to the depot and mess around with the gripper truck that's parked over there. Yeah, I'm gonna have to come back to this level pretty soon and finish it up. At least like the first, the MVP visual pass on this level. I need to get it finished so that we can get some nice pictures for the Steam page, and then I can finally actually reveal the Steam page to the world. And we can also start doing more stuff with Steam, like delivering builds through there and all of that. Whoa. Bonk. I'm liking this indicator already. I'm liking this a lot. Move everything back a little bit. Reset the arm. Try to get those boxes to fall back there at the end of the bed. They don't really want to do that though. I noticed you're using AngelScript for scripting. Do you script most game logic inside there or mainly in Zig? So AngelScript is used for adding logic to levels mainly. So like adding logic to data, if you will. In fact, what we've done in this very stream is set up this parking brake indicator here. Yeah, this is also done in AngelScript. We can now get rid of that commented out one. But I do this create canvas HUD handbrake indicator. I can't talk anymore. HUD handbrake indicator. When we add this to the view, and that is how we get that thing to show up there. This is AngelScript. It kind of just happens to be used for that as well. But I don't do a whole lot of sort of that kind of almost like system levels configuration or setup in AngelScript. AngelScript is mostly used inside of the level editor for quite simply adding logic to a level itself. So if we go into the level editor here, and we go to depot, because why not? Right, it's rendering the thumbnails there. That's why it's slow. It's also probably slow because we have the game running in the background, so we can shut it down. So I don't have a whole lot of logic in this level yet because I haven't, quite frankly, gotten to the scripting part of this thing yet. But let's script something here just for fun to show you what I mean essentially. Like let's say that when you've arrived here between these two cliff pieces here, something should happen. I don't know exactly what. Something should happen. Let's say we add some cargo here for you know, like for the player to pick up or something like that. So what we can do here is we can add a script to the level itself. So let's do script, Actually, let's not do script, let's do a trigger, which is a scriptable object. So we're gonna add it here to the base. Sure, that's fine. I'm not gonna save this anyway. So let's do a trigger, and we can make the trigger be maybe 30 wide, and let's make it 10 high, and then add the trigger here in between these two guys. I'm gonna be kind of sloppy with my scripting now. I guess I can't be arsed. Well, anyway, this is a script trigger. Let's make it a bit longer so that we can't skip it by driving over that rock there. So here's a trigger volume. Trigger volume has a script associated with it. It comes with a few functions, sort of as an example here, but we can see what we can actually do here. So on create, on destroy, layer loaded, on message, on object entered, on object exited, and so on. Well, we can just get rid of essentially all of that, perhaps except for on object entered. Let's set a boolean here so that we don't spawn a whole bunch of things every time something enters this. Then we can create a new layer, and we call it cargo, for example. And on the cargo layer we do crate. Let's put some crates here. There's one, and some more. Some of these smaller ones, maybe one of those. We take all of those, and we make them fall to the ground so that they're kind of placed there. Bloops. So then we have some cargo. Okay, and this is called cargo, the actual layer. So then we just do if not spawned. We do self load layer, and we need to give it the name cargo, and it doesn't need to be blocking. And then we do spawned is true, something like that. Now if we play this thing, and let's spawn a gripper truck for us so that we have something to actually grip that cargo with. I mean, I'm sure you get the idea of what I'm doing here. The kind of scripting that I'm doing is this sort of like one-off, hey, when you do this, then this thing happens sort of deal. So now when we drive here, boom, there's some cargo for us that we can pick up. Isn't that nice? And then you can try to pick up the thing. Yeah, that particular crate is a little tricky to pick up. You need to approach it from a very specific point. And so that's what I say when I talk about scripting. It mainly means things like this. I also have a visual scripting system that I use for scripting missions, for example. I can pick it up like that. But AngelScript is used more than anything else. It is used to add logic to a level. Right? You want something special to happen to a level, and you don't want to go into the game and modify the game just to have a piece of logic happen in this specific level when something happens in that level, because it's sort of like it's just logic for that one level. You don't want to have to modify the program for it. What I do with Zig is I don't consider that scripting at all. I consider that the game code. Like I know that Unity uses scripting as the term for like how do you actually make okay, have some inter or overlapping objects there that kind of mess that up so that they start jumping around. yeah, I know Unity uses the term scripting to sort of mean like write the game code for the actual program, so to speak. And when I say scripting, I kind of mainly mean just like, we need a piece of logic to happen here because, you know, this one person says something and then something happens in this particular piece of content in the game, blah blah blah. While, you know, the Zig code is mostly just like systems, essentially. You know, we have a AI driving component, for example. There's just like a whole bunch of code here to make the AI drive to places. And then I have something called Nemo, which is like the mission scripting sort of deal. So if you join the Discord, you get to play Pre-Alpha 1. And in Pre-Alpha 1, there is a single mission that you can play from the campaign, and this is the entirety of that mission laid out. And I do it with a flow chart like this, because then you can kind of read the mission. It starts here and it goes through these different phases, and it ends, you know, here at the end. And then, you know, if the player does something stupid and they kind of need to go back somewhere, then you can just essentially drag like an arrow to a previous phase and go like up. That's where we go back, and then it kind of starts to progress through this. And so we have a lot of this, like just like wait for condition, player at station or refinery. And we have a mission guide as find a way into the lift station. Then again we wait for some condition. Player is currently inside the station, or one of these other conditions that we're tracking here simultaneously. So this is also a kind of scripting that I do. Well, yeah, I mean, it's all kind of like semantics in a way. Doesn't really matter what you consider scripting and what you don't, and sort of what kind of code you write in what language. I happen to know that the Hazelight game studios, they use AngelScript for just like a whole lot of different things. So you can do that as well if you want to. It's not really an issue. I think they write most of their gameplay code actually in AngelScript. I wouldn't necessarily want to do that, but for scripting these kinds of small things, I think it's perfectly fine. All right. Let's see, what shall we still do today? Yeah. I think I'm pretty much done with what I wanted to get done today. Let's play this a little bit. So this is the level that you actually get to play if you download the Pre-Alpha 1 version. I should mention that it's pretty rough. Pre-Alpha 2 is also pretty rough, but has has some key improvements in some key areas. Yeah, let's spawn one of these gripper trucks here. This is a new vehicle, which you can actually not yet find in pre-alpha 1. You can see that it's not textured, it doesn't have sounds, it doesn't have anything. But it is pretty fun to drive around with and lift cargo and do things with. And I haven't really played around with it in this level, so let's do a little bit of that to finish up the stream today. And if you want to play the pre-alpha 1 version, and soon pre-alpha 2, you should join the Discord. The game is rough enough that I still ask people to join the Discord. But if you'd rather not do that, if you'd rather just wait until the pre-alphas are available on Steam, then you are of course free to do that as well. Let's just see if we can find some of these power cells. The power cells are sort of semi-randomly placed in the level, and one of your sort of missions, one of your assignments during this mission is to actually find a few of them. I'm not gonna spoil any more than that. We actually don't need these crates at all, but I just made this. Oh, we're gonna get stuck. Yes. Gonna get stuck there on the door, because everything is physical. Yeah, I just added the ability the other day to just click a button and the thing tries to actually like collect something and throw it in the back, and it's pretty fun to play around with. Is it Windows only, or do you also support Linux? It does run on the Steam Deck, but I don't have a. I only have DirectX renderers for now. I have run the core engine on Linux a few years ago. Should be said that it wasn't yesterday. It was a few years ago. At that point, I had a Vulkan renderer, I had a Vulkan backend. So I was able to do that, but I don't have that Vulkan backend currently. It has kind of deteriorated and I've let it go. So, you know, Proton is pretty good these days, but it's not a native Linux version, no. I am using NVRHI though, so building a new Vulkan backend shouldn't be the end of the world, and the engine is oh no, the engine has already proved itself in the sense that at least it used to work fine on Linux. I'm getting unstuck here. The unstuckifier, boom. So it's not impossible that I will eventually make a native Linux build just to see how that works, but for the time being it is Windows. It's Windows and Proton. But yeah, you can even run pre-alpha 1 on your Steam Deck if you have a Steam Deck. There are instructions on the Discord for doing that as well. If that makes it any better. If that makes it any Linuxier. With how far Proton has come nowadays, it's probably a wasted effort. That's kind of what I'm thinking as well, yeah. Yeah, Proton is really, really good. Before I put any work into Vulkan, I want to get D3D12 be working basically as well as this D3D11 backend. This is still D3D11. I have a D3D12 backend which has like, I have a to-do list of maybe like 10 points or something that I need to kind of fix up for D3D12. You can already play through this demo mission on D3D12, but certain things cause it to crash currently, so there's some stuff there that I need to fix. And before I do any kind of Vulkan stuff, I want to get that sorted out. What actually happens if I try to grab this thing? That could be an interesting thing to try. Kind of hoping that it won't work. Parking brake. Oh no, you can actually grab it. Oh. Well. Well, that's stupid. It's gonna be pretty difficult to actually drive around with this thing, but you can grab it because it's a dynamic object. Well, that's embarrassing, isn't it? The thing is though that most players actually probably won't have this vehicle when they come here. They will only get this later. But you can sort of, maybe that's just fun. Maybe it's just fun if people can mess around with it like this. Oh no! I'm gonna fall off the whole. I'm gonna fall off the whole ramp here. Yeah, let it go. Bye bye. Alright, well now I'm in trouble. This is a bona fide Austin Powers moment right here. All right. Do you still want to get a render overview? I can maybe end with that today if you want to. There's probably not a whole lot to see, but I can do that if people are interested. We have a total of 4 viewers. This wasn't perhaps the most popular stream today, but it's fine. I got done what I wanted to do. Oh shit. Yeah, you need to be really careful with how you drive when you have cargo. This thing just flips over kind of easily, but that's actually I don't think I'm gonna change that. Kind of like it. Kind of like the fact that there's a little bit of challenge in that. I would love to see it. Okay, let's end with that. It's been a pretty good stream. So yeah, like I said, it is a forward renderer, just a classic standard forward renderer, not forward plus, not any of those semi something things, not deferred, nothing at all. Let's close down everything, close all tabs. All right, the renderer, CBP. And basically this thing has a render function, unsurprisingly. larger for you guys. This thing has a render function. Render. You can also render off screen only. If you like, let's say I am building light maps, rendering light maps in the editor. I only render the off-screen stuff. I don't update the main view at all. And you can also have the render asleep, which might be weird. Like, why do you want to sleep? There are certain things that you still need to do every frame. For example, if you have imGUI or IMGUI, we need to sort of pump the IMGUI system. Otherwise, we're gonna go into a bad state. I don't even remember what this means anymore. Render slept. Right, okay, yeah. And there's some bookkeeping that needs to happen. And we bump the frame index there. But like, render is of course the main sort of thing here. So we can have a bunch of scenes, render scenes. We have the main scene, which is always there, but we can also have helper scenes. So for example, when we load the editor here, you can see that this thing starts rendering these thumbnails, and these things are actually rendered always kind of on the fly, so to speak. So we have like a house here. I don't store these anywhere yet, at least. I might do that at some point, but for now I don't do that because I don't have that many of these things. But these are all rendered to like an off-screen thing, and these are all rendered into other scenes, so they don't interfere with the main scene. So you can have a bunch of scenes, and we basically render the cameras. For the main camera, we render the full screen effects, and then we render the 2D stuff on top of everything. And so render cameras is probably the most interesting one. We have a render queue, which has a queued camera. Queued camera is just a small struct that has like a camera to render from. It's a render scene that we render, and it has an NVRHR frame buffer that we render to. And then it has some additional things. So you can render just like a single frame to a buffer if you want to. That is, for example, how those thumbnails are rendered. Just essentially throw one of these things onto the render queue for a single frame, add to back buffer single frame. Yeah, this is exactly actually what does that. And then it just renders a frame, and then it picks it off, like takes it away. And then you can have cameras that just are rendered until you stop the whole thing. Yeah, let's go back to render cameras. So we loop through all the queued cameras, and yeah, if we don't have a target, that essentially means like render to the main target. So if we are only rendering the off-screen cameras, and this happens to be rendering to the main target, we skip it. If the camera is not attached to like the scene graph, then we skip it. Let me check some options. So some of these are like immediately determine which kind of like sub-steps we run for the rendering. So for example, if we render particle systems, then we prepare the batches here and blah blah blah. Begin render operation. I think this nowadays does something. Right, okay, so this is now inside the render scene. Yeah, we need to prepare for the rendering in a few different ways. Begin render operation just like resets some things before we do anything else. Then there's also prepare for rendering, which I bet is called. Yeah, it's called right after that one. So these two can arguably be put together into one. Prepare for rendering just does a whole lot of figuring out the lights in the scene. Directional lights, that's the sunlight right there, spotlights, point lights. We calculate the sunlight shadow cascades and some other stuff. And then we write these to constant buffers. So here we have scene data, constant buffer, and some other things. And then we collect visible mesh instances. So at this point, from the camera, we can get the view frustum. And with that, we can collect the visible mesh instances, and we store it inside this batcher thing here, which we'll get back to in a little bit. So where are we now? Now we're back in render cameras. And that was the thing that we just looked at. So render shadows. This is the first kind of step, if you will. So render shadow maps. We go in here and we see we have sunlight. Then we render it first. And if we have any spotlights that have shadows, we render those as well. I don't have shadows for non-sunlight directional lights or for point lights yet. I should probably have for point lights, but I just don't have them yet. Render sunlight shadow maps. Actually, let's go to one of the more sort of normal ones. You can see here that what we're doing. Debug draw, calculate text positions for that. We clear the render target, terrain tire track map, terrain color map. These are just used to like color the grass and things like that. SSAO, this is of course rendered to like an off-screen buffer. So this is the HBAO version. This is the regular SSAO version. We render water reflections and refractions. And then we come to the sort of like main passes here. So we have distant objects and opaque pass. This is like where most of the things are actually rendered that end up on the screen. So distant objects are sort of like a special case of an opaque pass, where if you have depot, for example, just opening this all the time because it's reasonably quick to open. So we have this thing here in the background, which is just like all the way over here, and it's actually kind of like, yeah, we have this is exactly the thing. We have some weird depth effects going on here because like these are, some of them are rendered in the distant pass and some of them are rendered in the normal opaque pass. But like if we have this thing here with all of these different pieces, and it's rendered actually pretty far away from the level. The level is all the way over here. So I think it's like 4,000 world units or something away. So I have a distant object pass that make these objects use a different sort of depth distribution to avoid like Z fighting and things like that. For things that are just like all the way in the distance. Same thing for this moon here, for example. It's also rendered using the distant render pass. So we render those first, and then we render the opaque pass. And so here is essentially like the main rendering pass of them all. Then we have transparent, we have water, we have decals, we have volumetric lights, particle systems, editor gizmos. So the editor gizmos are kind of like rendered sort of like on top of everything else, because like you have this gizmo here, which is like kind of like in the scene, but it's rendered on top of everything else, so you can see it through this rock here, even though it would be kind of like inside of this guy. Just so that you can move things around. And then we do this thing that we already looked at. We decrease the number of frames that this camera lives. And if we want to have a callback fired, so you can ask the renderer to go like, hey, render this for me, and then call this function when you're done, so that I can use the results. For example, send these thumbnails to the editor. Then this is where we call, okay, now we're done. And then remove cameras that reach 0 frames. And we do some clearing here at the end. That's essentially like the whole 3D sort of pass. And then if we go to the main render opaque pass here and have a look at what we actually do, it becomes a little more complicated after this, because now we need to actually sort of collect the take the scene and collect what we actually want to do in there. So we take the scene of the queued camera and record render commands. And we do it into a render command buffer, which is essentially just like a memory, a piece of memory that is sort of like put aside to hold render commands. And we have all of the render passes here because they actually do things a little differently depending on what pass we are doing. Yeah, here we're actually, this is the distant objects pass. So here we are doing specifically that thing that I talked about. It's using build command buffer opaque, same as the normal opaque pass here, but it's just setting up another camera projection with those other depth values there. So we go into build command buffer opaque. We basically collect the meshes that we want to render. If they are static meshes, they go into a BVH, so a bounding volume hierarchy, so that we can cull like large swaths of the level in one go. If they are not, we just do normal frustum culling on them. And if we have a pre-computed visible mesh list, that's the thing that we looked at previously, we can just we can collect them here. If we don't have, then we need to collect the visible meshes here. And after this we start to generate these rendering commands. So the sky is rendered during the distant object pass, or alternatively during the opaque pass, the distant object rendering is disabled. Yeah, right. So we might be rendering the sky during this thing, and we might be rendering terrains if we have terrains and all of that. And then we start to issue like these kinds of commands. Set camera. So into the command buffer, which again gets passed in here as a parameter, we allocate commands. So set camera is one command that we can allocate. And then if we render sky, we just allocate one of those commands. And then if we have, well, sub-meshes, but essentially meshes, a mesh can contain multiple sub-meshes. But if we have any meshes, then we quite simply loop over all the meshes that we have. And here we try to merge commands together. So command is basically like, if the material has changed, then we can't merge. If the, let's see, if the batch is full, then we can't merge. Or if this draw data compatible with command returns false, we can't merge, but otherwise we can merge. But basically we whenever we render a batch, so a mesh that has a material that has like 10 instances, it gets one of these bind material commands allocated for it, and then it gets just a whole bunch of these draw instance submesh commands allocated for it, and they all get put into a command buffer. So allocate command essentially just means create a new instance of the command, placement new it into this piece of memory, and push it to a list, so that we can execute it later on. And after the meshes have been rendered, we render the terrains, and then we do the decoration batches. So some of these objects here in the scene, stuff like these rocks here, these won't end up as actual game objects in the level. They will end up as so-called decorations. They could just throw a whole bunch of them into the level, and they are pretty lightweight to render. So we have a separate path for them. And then we have some editor stuff here actually. If the editor is included, which it is not in the final build, then we can render some editor icons and things like that. That would be like these things, this kind of stuff. Here's a blocker, and we actually got one even for that trigger that we created here. And that's it. That's you know, when we have come out of this build command buffer opaque, we have a bunch of render commands in the render command buffer. So what do we do then? Well, we've done it here. Here we quite simply see, hey, do we have any commands in it? And then some other checks as well. And then we do a begin main render pass, end main render pass. In between it, we have something called a render command runner, which takes, you know, this command buffer. At this point, we're approaching the NVRHI level, so essentially the graphics API level. This used to be just a few months ago. This used to be where I handed it off to my own platform abstraction, which in turn gave it to like D3, D11. Nowadays I use NVRHI, so this is an NVRHI command list, and this is an NVRHI graphics state. But the runner is comparatively pretty simple. It does run things in two passes. So the first pass collects the data into batch and instance buffers. This is just to like further, you know, be able to compact things together and like actually blast through the whole buffer in one go once we have like all the indices and everything set up. But you can just call source buffer restart to sort of jump back to the beginning. I think this literally just sets like a, yeah, it just sets a read position to 0. And run command phase 1. This is just a switch case. We're not interested in a whole lot of different commands here in the first phase. We just do instance submesh. So this was one of those commands that we added when we were rendering the meshes, and then the decorations, because they both are then sort of rendered in batches. So we just figure out, okay, how many of these guys do we have, and then we add them to the batch data, which is just, you know, indices essentially laid out in a thing here. Render batch data. I think this is, yeah, this is a struct. So this is stuff that we can push directly to the shaders. You can see here that we're actually sort of padding things correctly at this level, because we want this to match the HLSL stuff. Now we put, so this can essentially just be mem copied into a the const buffer. So that's what the command run command phase 1 does. After it's done, we actually do the buffer updates. So update instance buffer, we write in the command list to a buffer. This is a structured buffer, so SB. And once that is done, we can do the second run command phase 2, and this is where we actually do the rendering itself. So here we most likely react to every single render command that comes in. So bind material actually just gets this thing and stores it somewhere to be finalized later. But draw instance submesh, this is where like the whole, this is where all the meshes get rendered. So we have a command. The command has a mesh, has a LOD level, it has a submesh. Hey Wookie, welcome back. We get the material that we essentially bound here, and from that we get a batch data, and then we see if the submesh has like a vertex buffer itself, then we use it. Otherwise we get a temp one. And this is just like NVRHI data now. So we set up the draw arguments, we set the graphics state, set the push constants, and we either draw indexed or we draw. I think set material to graphics state, this is where we bind the PSOs and all of that, isn't it? Yeah, we get the material and set to graphics state. This is where we do if I don't remember incorrectly. Yeah, here's where we actually get the PSO. So the graphics pipeline. This is where we bind all the shaders and all of that. All of that stuff. What is that? Oh, it's the bindings, yeah. Yes. That is it. Yeah, the material is a whole other can of worms. This is probably, well, it's over 1,000 lines of code as well. Thank you for showing. No problem. As you can see, it is kind of annoyingly convoluted in many ways. You know, considering what we get out of it, this is not the most beautiful thing in the world. But I don't think there's really any way around that. Like, renderers tend to get complicated, annoyingly so. There's some things that are kind of neat with doing it this way, where you abstract like certain parts of this. Like you can, when you have a source buffer like this, render command buffer, you can run it, or you can run it with an overridden camera, for example. That's one way, and then you can just give the camera data here like this, which means that like I can render the same objects from a different point of view, for example, for doing like reflections or whatever. That's kind of neat. You don't need to collect all of them and sort them together into batches and all of that. You just take the same source buffer before you throw it away and run it with the runner on you know, with another render target or whatever, and it kind of just works. And you know, then you have the whole shader generation thing, which is also a whole thing in itself. So I used like a node-based thing for that as well. We have a vertex face here, and we have a pixel face, and then it generates some code that looks like this, that we can throw onto the shader compiler, and then it tries its best to generate shader code that like works with D3D 11 and 12 and Vulkan. And you can sort of see where each node begins and ends from these comments, all of that. So yeah, that is how it works, and in many ways I wish it was simpler. I wish it was more elegant, and it could probably be made more elegant if I started again today. But it is what it is, and this thing is what is going to be shipping this game, and then we'll see what happens after that. It is, after all, working well enough, I'd say. Alright guys, I think we are pretty much done for today. So this was a pretty good stream after all. I got a little stuck there trying to figure out that handbrake icon and the colors and the blur and everything. I think this is probably going to be what I'm going with for now. Just no blur, no funky colors, just a white icon that changes slightly whenever we are in the parking mode. Bonk. yeah, stuff like that can sometimes happen if you have a lot of objects that you are sort of trying to pull one specific object out of a pile. I might have to rethink how I do the sort of detection if like of detection of when is an object actually kind of gripped by that claw, because currently it sort of just checks for some forces there. But sometimes if you have a lot of objects, then the force can be pretty large, even though you haven't, or at least it sort of looks like you haven't gripped the object. So it can sort of just like, it can lift it even though it looks like it hasn't really gripped it necessarily. But that's not really a big bad problem. Let's try to drive this thing without spilling our cargo to the depot, and then that's probably going to be it for today. It is so easy to drive too hard on these dirt roads. Oh, another thing that I did actually since the last stream. Last stream we got stuck with this thing just all over the place. And what I did was actually I ported my custom differential code from PhysX 4 to a fork of PhysX 5. So now I have a little bit of a custom PhysX version that I use for this. The only changes that I made are to the vehicle SDK, but they are pretty good changes. And it also allows me to detect whenever PhysX wants to enable the handbrake, like now, for example. So let's do open and unload the cargo. Right. I thought I was gonna be able to drive away before that happened, but evidently not. Anyway, I think we're pretty much done for today, guys. Thanks for hanging out today. This was a pretty successful stream. If you haven't subscribed already, I would appreciate it a lot if you did. And, you know, tell your friends, tell your colleagues. Do join the Discord. There's a link in the description below if you want to play the Pre-Alpha 1. Pre-Alpha 2 is coming relatively soon. And before you know it, there's going to be a Steam page out as well. So do look forward to that. And still hoping to put out Pre-Alpha 2 during the summer. It's getting a little tight to do that, but maybe I'll manage. But if not during the summer, then at least at the very end of the summer. Looking forward to your next stream. Well, thank you. That's encouraging. Thank you for the kind words, and welcome back another time. Have a great rest of your day, everyone. See you next time.